Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at database management system, and for today's module, we will be looking at normalization. Some of the learning objectives of today's session include the introduction to normalization, history talking about how normalization evolved, purpose of normalization, redundancy and data anomalies, meaning of repeating groups, meaning of functional dependency and transitive dependencies. To start with, as an introduction to database normalization is a process of removing redundant data. By redundant data, we mean we are about to eliminate data which are repeating or appearing more than once in a particular table. So, we start with this definition. Database normalization is a process of removing redundant data from tables to improve. So, these are basically done to improve storage efficiency, data integrity and scalability. Earlier days, there were problems storing ample amount of data which are found to be redundant. So, storage was cumbersome, there was not sufficient storage which is available earlier days, and people were not scalable, or the system were not scalable to many certain relations. So, for these reasons we have shifted to database normalization, whereby we can optimize on the number of relations being present. In the relational model, methods exist for quantifying how efficient a database is. These clarifications are called normal forms from now on and are notated as NF. And there are certain algorithms for converting a given database between them. So, the procedure of normalization is being carried out on different stages. Each and every stage in this process of normalization does a certain amount of task, by where certain removals happen, after which the finalized result will be a table with a completely normalized activity, basically removing the redundant information. Further on this normalization generally involves splitting existing tables into multiple ones. It is, so far we have looked at a relational database table as one single table, or when we looked at relational algebra, we have considered two different tables. But by now, because of normalization, we will be trying converting the relation or splitting the relation into multiple relations, which must be rejoined or linked each time a query is being issued. Whenever there is a query posted for this particular table, it does not actually say these tables are converted into multiple tables now. Instead, it takes in the query, converts the query into appropriate format this normal form needs, and answers the query as though it is one single table. So, how it could be done effectively? Talking about the history of normalization, Edgar F. Codd first proposed the process of normalization and what came to be known as the first normal form. This was introduced in his paper titled "A Relational Model of Data for Large Shared Data Banks." When there was a large sharing between data, how could a relational model effectively store and retrieve all the data was the concept that he has introduced in this particular paper. There is in fact a simple elimination procedure which we shall call normalization. Through decomposition, non-simple domains are replaced by domains whose elements are atomic. Atomic in sense, every attribute in a particular relation should have only one single value. So, this is non-decomposable values. So, by the way of normalization, as far as first normal form is considered, we will try converting every relation into atomic values. Further, Edgar F. Codd originally established three normal forms, not only first normal form. After having successfully completed the procedure of first normal form, it can go for another task of second normal form, and it can take up an additional task of performing a third normal form also. There are now others that are generally accepted, but third normal form is widely considered to be sufficient for most applications. As I have already indicated, normalization is basically done for storage efficiency, scalability and reliability of a particular system. But if you consider today's world where storage is not a concern, people are talking about cloud computing, where we can take whatever that is needed from wherever the system is. So, this kind of cloud computing concept does not require normalization or multiple entities available in a particular relation, but then normalization is a very exact procedure of how these records are stored in a database. So, as far as this normal forms are considered, although there exist several normal forms, majorly first, second and third normal forms are considered to be the best normal forms that are available. If you look at these normal forms, each and every normal form does a separate operation, by where it is to ensure, say, repeating groups are avoided. So, every value that is available in a particular attribute being atomic, or by performing another level of normal form, we maintain full functional dependency, or by doing another level of normal form, we maintain transitive dependencies. Likewise, every normal form has its own purpose to be solved, but to perform third normal form, we should have done first and second normal form. That is the indirect implication. Now, let us try to understand the purpose of normalization. The purpose of normalization is basically to avoid redundancy by storing each fact within the database only once. So, there should be only one value which should be available for every field in a relational database. To put data into a form that conforms to relational principles, for example, single valued attributes, each relation represents only one entity and there are no repeating groups that are available in a relation. The other purpose is to put the data into a form that is more able to accurately accommodate all the changes. There could be certain level of anomalies that could happen when we store all the database values. So, we can accurately accommodate those changes by putting every data into one single format, which is now supposed to be called a normalized format. And to avoid certain updating anomalies, when there is an insertion, deletion, updation, there can be certain level of anomalies that can exist in this particular database, which can often be removed by the procedure of normalization. And by normalization, we can facilitate the enforcement of data constraints, by where we ensure integrity of the data. Let us consider a simple example of a table which has the complete list of a book detail. Any book that we consider has these attributes, say title of the book, author, there will be multiple authors, say author 1 is one particular field or author 2 is another attribute, the ISBN code of this book, the subject, title, number of pages being written, and finally the publisher. So, these are the complete list of details that are stored as a relation if we consider a book. Now that I have given two different books here, one is on a database management system, the other one is on the operating system concepts. It is found to be the similar author who has written these two books. So, Abraham Silbersatz, Henry F. Coates, which are found to be the popular books, they have written two different books on two different concepts, but the ISBN number and other entities are completely different. So, what we try to infer from this particular table is this table is not very efficient in terms of storage, because we see repeating entities available as author 1 and author 2. This design does not protect data integrity, the validity of the data, and finally, this table does not scale well as it proceeds further. So, what we tend to do as far as this normalization is concerned, we see some repeating groups that are available as authors in this particular table. Now that these values are to be removed and to be stored as a separate entity or as a separate relation. So, that is the basic purpose of normalization. Let us try to see what are the basic properties that these normalization would commonly imply. First, we will talk about redundancy and anomalies. Redundant data is where we have stored the same information more than once. As I have already indicated, the same data which is available in a particular field is been repeating more than once in the same table, then it is called a redundant data. That is, redundant data could be removed without the loss of any information. So, the major purpose of removing redundancy by performing a normal form is to remove this particular data without any loss of this information. Say author 1 and author 2 had to be separated as a separate table, but then the author names are to be stored as such without any loss. As another example, now that we can consider the following relation that contains staff and department details. If you look at this particular table, this has got 5 different attributes like staff number, job, department, department name and city. If you look keenly into all the tuples of this particular relation, staff number is supposed to be an unique identification. So, it is called a primary key, whereas job is not so. If you look at job, there is a person who is available as salesman, there is a person who is called a manager, and there are few clerks who are working for a company. And likewise, there are departments which has people who work as managers and clerks, and there are department names associated to those department numbers like accounts department, and there are cities which has same name. Now that we see a lot of redundancies available in this particular data. So, such redundancy could lead to the following anomalies. What could be the anomalies? So, the anomalies can be of these types: insert anomaly, update anomaly and delete anomaly. If you look at insert anomaly to the table that we have considered, we can insert a department without inserting a member of staff that works in that particular department. If we want to insert a department, we can insert a department number without inserting a member who works for that particular department. That is very much possible in this particular relation. As we know, there should not be any null values that should be associated with it. So, this insert anomaly is very much possible. Likewise, we have another anomaly which is called update anomaly. With the previous table that we have considered, we could change the name of the department that SA51 works with. If you look at the same table, SA51 has a job of manager and he works with accounts department with department number 20 and from a particular city. We could change the name of the department that SA51 works in without simultaneously changing the department that DS40 works in. So, that can also happen. And finally, a deletion anomaly where by removing employee SL10, we have removed all the information pertaining to sales table. That means, if I am to remove the value of SL10 which is supposed to be a primary key, if I tend to remove SL10, it simultaneously removes department 10 which is supposed to be sales department. So, if I remove this particular value, then it means if I am removing the salesman along with its sales department, which can never happen in a company. So, these kind of anomalies are to be treated by performing a normalization, and thereby we ensure redundancies and anomalies are not there completely in a relation. Now, we will start defining about repeating groups. That means, we have a lot of redundant information. So, a repeating group is an attribute or a set of attributes that can have more than one value for a primary key value. If you look at this particular table, we have the following relation that contains staff and department details and a list of telephone contact numbers for each member of staff. I have added only one column on top of what was existing as a previous table in terms of anomaly. In this particular table, we have staff number. Say for SL10 as salesman, there are a list of numbers which are associated as contact numbers in this particular relation, which is not possible as far as a relational database table is concerned. And each and every number should be unique. A field can accumulate only one number, it should not be separated by a comma. So, repeating groups are not allowed in a relational design, since all attributes have to be purely atomic. That is, there can be only one value per cell in a particular table. So, this cell of contact number can involve only one value, and a value which is associated with a comma operator cannot be taken up. So, how this can be converted is a simplistic solution being contact number 1, contact number 2, contact number 3, since the entire table has maximum of 3 contact numbers. But if you consider this particular relation, for row 1 this will have 3 contact numbers, for row 2 it will have only 1 contact number, others are being stored as null, and for row 3 almost all the contact numbers are stored as null, and for row 4 we have only 1 contact number. So, by where we are trying to ensure that all the values in a particular cell is purely been atomic, that is, it can store only one value. The other property that we will be looking at is on functional dependency. We will try to define what functional dependency mean. Attribute B is functionally dependent upon attribute A. So, consider we have two different attributes, attribute A and B. Attribute B is functionally dependent on attribute A if we write A implies B, or a collection of attributes, need not be only one attribute, it could even be a collection of attributes. If a value of A determines a single value of attribute B at any one time. That means, if I am trying to notate it formally, A implies B, this should be read as A determines B, or B is functionally dependent on A. It can be read either ways. I repeat, A is determines B, or B is functionally dependent on A. In this, A is called the determinant and B is called the object of determinant. This object of determinant is purely or functionally dependent on determinant. If you look at this particular example, having 4 different attributes: staff number, job, department, department name. Let us look at what are the functional dependencies that this relation has got. Staff number implies, or staff number determines job, or job is functionally determined by staff number. Staff number determines department, or department is functionally dependent on staff number. Staff number determines department name, and we could say department name is functionally dependent on staff number. This is primarily because of the reason that staff number is being assigned as the primary key. But then we could surprisingly see a particular relation between department and department name. Every department name is not purely functionally dependent on staff number. Instead, every department name is dependent on department only. As far as this relation is concerned, department name is associated with staff number also, whereas in general department name is purely assigned to department only. So, we write the last relation which says department determines department name, or department name is functionally dependent on department. So, as such we look at this particular relation of functional dependency. Considering the previous example, we have seen one relation or one attribute determines the other attribute. It could even be a group of attributes which can determine on an attribute. That can also happen. In that particular case, it can be called as composite determinants. A composite determinant, if more than one attribute is necessary to determine another attribute in a particular entity, then such a determinant is termed as composite determinant. As such, if a list of values or a group of values determines one attribute on a particular relation, then this is supposed to be called a composite determinant. The other thing that we may have to talk about in this particular relation of composite determinants, if in case we have a group of attributes that are dependent on, that determines a particular attribute, then comes the case of whether it is fully functional or partial functional. Let us try to define what fully functional dependency mean. Only of relevance with composite determinants. This is the situation when it is necessary to use all the attributes of composite determinant to identify its object uniquely. That means, if we consider the relation that we have explained, department name is not fully dependent on, department name is dependent both functionally dependent on staff number and department, but then it is not fully functional on staff number, but it is fully functional dependent on department alone. So, in that particular case, department name is fully functional dependent on department and not on staff number. We will consider another example for this fully functional dependency. Here we see an example which has got 4 attributes: order number, line number, quantity and price. If we look at fully functional dependency, order number and line number determines quantity. That means both the attributes together determines on the total quantity that is required, or it could even be read as quantity is fully functionally dependent on order number and line number. Further, there is another attribute called price, which is fully functionally dependent on order number and line number. Sometimes there may be a case where price is dependent only on order number. In those specific cases, we cannot call this as fully functional dependent, then it becomes partial functional dependent. It is primarily because order number and line number together is not a determinant of price. So, it is partial functional dependent. So, in this particular case, we have hinted saying order number and line number purely decides on quantity and price. So, order number and line number determines quantity, or these relations are to be read as, since it is compound determinant, these relations are to be read as quantity is fully functionally dependent on order number and line number. Price is fully functionally dependent on order number and line number. So, as we have said in the previous case, we will try to understand partial functional dependency also. This is a situation that exists if it is necessary to only use a subset of attributes of the composite determinant to identify its objects uniquely. So, in this particular case, as I have already hinted, if there are more than one attributes which determines a particular relation, then it becomes composite determinant. But in this particular case, as we have clearly indicated, partial functional dependency, the determinant or one of the determinant or one of the attribute that we have presented defines on this particular attribute. That means a particular attribute which has been derived is partially functional dependent on this particular attribute. So, in this particular example, we have got 4 attributes: student number, unit number, room and grade, where we find repetitions that are available in specific rooms, that is CH-224, more than one student may be there. If you look at the fully functional dependent available in this particular relation, grade is fully functionally dependent on student number and unit number, whereas room is dependent only on unit number. Of this particular relation, room is dependent only on unit number and not on student number. Student number and unit number being the primary keys of this particular relation. So, in this we will say grade is fully functional dependent on student number and unit number, whereas room is partially functional dependent on unit number. So, that is how we define functional dependency in relevance with this normalization procedure. In summary, in this particular session we have looked at the introduction of normalization as Edgar F. Codd has defined. Then we have looked at the history of normalization, where as a effective paper, a technical paper, it was initially defined with the first normal form. Then we have started explaining about the purpose for which normalization is being done: to maintain the storage efficiency, to maintain the integrity of the data, and towards scalability. Then we have talked about some of the concepts like redundancy and data anomaly. We have started saying about repeating groups, and we have defined on the functional dependency, which in turn had 2 classes: fully functional dependent and partial functional dependent. Thank you.